In this episode of my Android Java programming, I'm going to explain an excellent modeling and visualization tool which I learned about a couple of months ago, but I haven't used it so far in a real situation, just some experimenting. But because today my application is getting shape, so I'm going to show how to use a tool like that. The good thing that it is called PlantUML, and this PlantUML is nicely supported by a tool called Navigator. What kind of navigator is that? I think in preferences, plugins. Yes, installed plugins. Yes, Markdown Navigator. So this Markdown Navigator has, when you installed, even the free version supports nicely PlantUML diagrams. If you are interested, just check out the PlantUML website. This is not going to be a tutorial. What I'm going to show how I use for a real application development situation. The file is available here in my, this is the file I created, module architecture.puml, and then with this this file, it's a text file and also a brilliant, I would call it a kind of artificial. Microsoft used to have a very similar brilliant tool, and but this one is maybe not that fancy as the Microsoft tool was, some graphing tool, but this is good enough either. And interestingly, the color scheme, the default color scheme, is very similar to rational rows, yellow and burgundy coloring. Anyhow, so this was my original architecture drawing, just a sketch where I have the packages, meaning these package symbols B1S are the modules. This is for the repository and the data sources, actually the API. This is the package which has all the components doing, let's call it the business logic, and then has the communication towards SAP Business One service layer. On top of all of them, I have a model. This model is independent of everything. These are actually just more or less plain old Java objects, serializable, and this is the territory of JSON and the JSON structure. So this, in my architecture, this model is going to be used directly by everyone because it doesn't depend on anything. They are just so ViewModel. Now let's first discuss the APP. This is the application, the user interface component. That's where we have these activities, login activity. These are the fancy names in Android for the screens. So activity is actually more or less a screen. Of course, within an activity you can have fragments. So therefore an activity screen could have a number of layouts. These are called fragments. And then this user interface, actually this is the application and all the data behind the screen. So normally the screens, these activities shouldn't have any instance variable, at least have non-technical instance variable. So all the data that are relevant to our application should reside in view models, and this is the architecture. This is the view model, model view model architecture, which I think maybe Microsoft invented it, at least promoted their Xamarin Forms architecture, which was really brilliant, that architecture. And then exactly the same architecture was adopted by Google team to promote this model view model architecture. And in this architecture, the idea is that every user interface, significant user interface component or a group of components has a background view model component, and all the data, application specific data, are residing here. All the application logic decisions are made here, for example navigation components, and then this is the I would call this application logic versus the business logic, and this application logic of view model is responsible to keep contact with the business logic layer, and then channeling the actions from the activities, the user interface, towards the business one or the business logic layer, as well as when the data are received normally, typically in an asynchronous way, channeling back to the user interface using live data. So this is the architecture I'm going to model with my application, with this PlantUML. I don't write everything, but I just want to make it how to say, more up to date, because in the meantime I first initially create this diagram. I have modified the names, mostly the names. Let's come to the B1S layer. Oh, the model layer. This is independent. Okay, I would definitely I don't have model, so this way you will have the how it is used. So instead of your user, let me just replace this user maybe with the B1 session, and I think this is called view, no, edit, and fine, replace. Yes, this is what I was looking for. Replace the user with B1 session. Okay, and immediately the diagram is updated. And then let me just add additional model elements like B1 activity. I don't include the technical B1 error, B1 exception, login requests. They are not that important. B1 activity is definitely interesting. So when I entered here, these are components. This is the syntax for components. I'm using only components here. I could use also classes, but for this demonstration I use only components. B1 activity, and then this B1 activity has a relationship with the B1 activities, and then this is a list B1 activities, and yeah, oh, this is the composition. Anyhow, just leave it a simple line. I don't remember what is the symbol. Ah, let's check out in the PlantUML documentation what is the syntax for PlantUML. Okay, component diagram. Let me see what do I have here as basic. I don't find the the line I am looking for. Okay, then let's go back and see if I have a class diagram. Yes, composition, aggregation, and extension. Okay, I think this is what, maybe this one. 20. Aha, I think I can use this. This is a multiplicity specification. So this is the symbol. Okay, let's come back. Uh-oh. But it didn't work that way. Very interesting that here it is not complaining. Okay, then let's use this X. I don't know why it is not supported. Interesting that they are included here. Maybe it doesn't support with okay, then let's have at least this direction. That is a B1. No, the other way is correct. The B1 activities has relationship with the B1 activity. B1 activities is practically a list of the components. So this is activities. Okay, so for now that's fine. Let's move on to the B1S. Maybe login data source. Okay, this is B1S login data source. I just renamed it again. Let's rename this data source and replace it with a lot longer name, B1 login data source, maybe impl. Yes. Okay, and then also this login ds, let's just replace that with b1 login data source and interface. Yes, yes, b1 data source interface. And then let me just add another component, and this is b1 activities data source impl. This is the implementation, this is the Java class, and it provides an interface, implements an interface called exactly the same name, but with int. Yes, this is how it looks, source interface, and I also include the retrofit interface. b1 activities retrofit interface. If you are familiar with retrofit, you know what I am talking about, and this implementation is using that interface. So therefore the dependency is, for example, yes, this is the dependency. So the interface is provides, but this is not a package, this is just an interface. Exactly, this is just an interface, just like this. This is not a package, this is an interface. Excellent. So data source implement, it uses the depends on the retrofit interface and provides the activist data source interface and the repository, and the repository should be renamed to data source repository. Repository data source repository. Here you go. And this data source repository also has dependency towards this implementation. Yes, because this database repository, this is a factory, and then whenever someone is get login, I guess this is also renamed. Let's check out in the source file in this repository what interface it has. It has a get login, it remains the same, but it also has a get activities function, and then this function is available to the ViewModel classes. So yes, data source repository also provides this interface. Okay, but it's on the anyhow, doesn't matter. And the up view model I have here, this has also dependency on this interface. So up view model, I just copy this, and then this is the get activities. But this no, this is wrong. This is a dependency, sorry. This is the dependency. So the way it works, the up view model, when it requires a service from the B1S module, the fact it has a reference to the data source repository via these two functions, either calls the get activities ds or the get login ds, and then based on the implementation, the data source repository returns either the login data source implementation, but the view model is exposed to use only this interface. So therefore, let's just add another dependency. This is terribly important, that we are using here the login data source interface. As well as the activities data source interface. Yes, this is what we have here. So the up view model calls a get activities ds, for example, and then the data source factory creates an instance of this B1 activity data source implementation, which has this data source interface, and then this is what the up view model is actually using. That's why we have this dependency here. So definitely when you want to draw just an overview diagram, this is not an overview diagram, this is more so, but it shows you the intricacies and the details and the internal dependencies of this application. So the retrofit interface is never exposed to outside, so it's not really used outside of this B1S. So that's why it is also very important, as well as we have another retrofit interface here, and this one is the login retrofit interface. Let's come back to the package. I have here the retrofit interface. Let's copy this one, and this retrofit interface, instead of the retrofit interface, the name is B1 login retrofit interface, and it is implemented, it's used by the login data source implementation. Yes, so the nice thing with this PlantUML support of this navigation plugin is that you have, so when you define your components, it shows you that what components are available. Yeah, so this is here our my understanding that we have some possibility to rearrange our drawing when you something like that. This way maybe it's easier to to lay out, and for example if we want this to be down, I think we can enter, this is the B1 activities. Yes, this one, I think here we can enter characters like D, meaning down. Yes, but this is not what I wanted. I think yes, these are the possibilities what we had, but it didn't help a lot. So let me just move it the other direction. Actually it is fun to work with when you know what you are doing. Yes, now it's okay ish. I don't understand why this is so far away from this login data source. Interface, login data source, login data source. Why not just make it on the other side? Left, right. No, it didn't have R. Maybe L. No, he doesn't want to move down. Down is the default, sorry, and up. Whoa. Wow, now I think this is now what I like. So this is the way you can, so U means up. So now you have some option to arrange your diagram somehow. And what is interesting though, and of course also this implementation is using the service layer, but not directly, or let's go not really directly, but via this login retrofit interface. So from login data source I move this line to the login retrofit interface, b1 login data source impl, not to the service layer, instead login retrofit inf, retrofit inf. Yeah, it's not a package. Yes, so now we have all the channel and also B1 activities. Okay, cool. So that is, now we had B1 activities retrofit interface. So to this retrofit interface actually are used for the communication with the business one service layer. Yes, so this is the B1S package. Let's concentrate now. Application view is just two objects, nothing special. The model I have already covered. The B1 activities, yes, that's who is using. Actually, these are really used by all the applications. So you can draw your diagrams here and there, but because this login activity now is in just an experimenting phase, so at the moment it has direct access to the B1 activities, but definitely, yeah, we can draw a line from there too, just for the sake of completeness. Let's do it that the login activity has a dependency. Let's copy it and then get login VM. Instead we have B1 activities. Yes. Yes, this is login activity, and now it has dependency to the V1 activities. To yes, it uses the B1 session and B1 activities either, and then it uses two services. And then let's concentrate on the view model now. App view model, it's okay, and view model factor is the same, but we have also two interfaces and two functions. Yes, this one, this iLogin VM, I renamed to B1 login VM inf. Okay, so here in VM I rename this iLogin VM. Let's rename it. This to B1 login VM inf. Okay, so this is now the correct name. And the get login VM, let me see if this is the name, because in the factory you have, yes, get login VM and get activities VM. So these are the two functions that returns actually the view model. The trick here is that in every case the view model is created, but the trick is that this view model provider always returns the same object. So it's really a fancy way. This is the Android architecture component. Anyway, so we have also the get activities VM. So let's add this get activities VM to here. Yes, I have this get activities, which is also used by the login from the package. Get activities VM. Okay, it is significantly redrawn. So the view model now, okay, so this is the application, now has dependency. So two interfaces, two functions, the get view model factory. Okay, cool. App view model, and the app view model implements the login VM interface as well as the this login VM interface, and also V1 activities VM interface. T yes, VM yes, this is another interface, and the login activity is dependent on this too. These are interfaces. I don't know why I used here this package syntax. No, this is the interface, and B1 activity is VM interface. So login activity now has all the dependencies. Yes, excellent. So as seen, the login activity has all its dependency via the ViewModel factory, and then all the actual transactions are done via these two interfaces at ViewModel. So a good architecture, especially in Java, Dart, C#, even in TypeScript, where the concept of interface are available. This is typical because when you have an interface, actually the only thing you have to do is, when you want to understand the architecture of your system, first after you have a diagram, you just check out, for example, what is this maybe let's check, maybe this one, login VM interface. If you open this, you can see immediately what are the possibilities. First of all, this ViewModel provides live data streams to be watched. Of course, these are the data where the activity, the user interface, has the data, the login form state, login result value, B1 session, logout result is just a regular integer, and then the error handling. So these are the channels. Normally, if you want to implement this in your activity, you have to consider that, have I implemented this stream, have I implemented, so these are the values which are pumped as a streams towards, from the ViewModel towards the activity. And then here comes the other direction, when this is absolutely not important, when I really hate it, I will delete it definitely, it just overcomplicates our life. The other direction, these are the services, these are the entry points of the events that you could use from your user interface. The login async, login data changed, and logout async. Because this is for the login VM interface. I show the other interface. What does it mean? That pay attention that when you use this the user interface, the login activity, the screen calls the login async function. The async is terribly important in my opinion, because now you are sure that this login will return immediately, but behind the scene it starts doing something, and then it returns the value via any of these channels. In this case, the login result, which is returns a B1 session asynchronously, or the error. The error handling is terribly important all business applications. The login data changed here is just a validation. Doesn't have the suffix async, meaning this is a synchronous. That is just for validation, and you receive immediately the response from this function. And logout, I think, is similar to the logout, but get logout result. And this log inform state is just another cool thing. And then the other ViewModel interface is the V1 activities, where again the concept is similar. Get activities. Actually, this is the the result of the query activities, and then again error handling. And query activities async. Let me show you immediately a tricky thing, that in the application how these view models are received. For example, in my case, here you go. So this is where the view model is connected to the activity. At the moment this is not using the data binding. The next iteration I will rework the whole thing using data binding. Actually this is more or less the way this Android Studio Visa generated it, but of course I modified it significantly, but I haven't already implemented data binding. So login VM, get the login VM. So behind this ViewModel factory is actually using the Android architecture lifecycle management to get the proper ViewModel for that. And then, because this is the login VM is just an interface, so from this perspective the activity doesn't have any clue how behind the scene it was implemented. And actually in my case I have two interfaces to provide more modularity. Modularity, it's not necessarily from the perspective of the architecture itself, but for the project management. So when you are working in a team, you may have a separate team who is responsible of working with the login interface, another team working with the activities interface, and actually yes, these two teams are working in a modular way, in multiple modules, but at the end, from the perspective, they are visible as they are separate. But here there is a trick that this activity checks if the login VM is exactly the same. Does it implement the B1 activities VM interface? Yes, it finds that it acts, so that's you can safely then you can safely just simply how to say, use the same same reference. It is called casting. And then if this is not the case, only then calls the ViewModel factory to get the activities ViewModel, because in that case possibly the ViewModel factory is creating a separate ViewModel for this activity. So that's a possibility. And then the activity, the user interface, the screen is really independent. So unfortunately in my case this B1 activities has nothing to do with the Android activity. Android activity is a screen, a business one activity is a task, a phone call or something like that. So this is a business concept. That's why I prefix it B1 activity. Right. And then back to our diagram. This is modeled nicely here, and then when you have a diagram like so, you can explain and visualize these dependencies a lot. And then while you are making these diagrams, one of the big advantage, you the architect, the designer, has the option to review, rethink, validate if your design is okay, every component are available and everything are in place. So this is typically an application where you can expect, in my opinion, 2 or 3 people would be optimal to implement it. One guy writing the business one, parts and components, and another one for the view model as well as the user interface. And the third one is maybe just implement the corresponding components in the service layer in the business one side. Tables, user defined fields, and these things. I think that's all what I wanted to show today. Before leaving, let me just come back quickly to this login activity. What fancy thing has been done here? First of all, this lambda. So this was the original syntax in Java 7, this new observer and override public. And then later we have here another lambda expression, like so. And then when you have again this method reference possibility, you have this reminder. So therefore I implemented my observers like so: get login result, observe, and unchanged login result, unchanged logout result, unchanged activities. And these are with this is the method reference that here I have all of them at the bottom. And this way, in my opinion, I prefer this a lot better than applying for example this style, these anonymous objects and classes defined. The reason I prefer this, because then these components has names, and when you have names you have the option to design them, to reference them here in your diagrams, in your modeling tools. If you are working only with anonymous objects and classes like so, then it's very hard to model them. For example, check out this one. This is a login form state. And therefore, how can you model it? It doesn't have any name. It's just an anonymous observer implementation here. So that's why I think for a complex application where documentation is important, maybe this is the way to work. And then what is good with this, that you can use this very simple technique. So to me, this technique is more like a declarative way of programming rather than this. This to me seems really cumbersome than this other way. So anyhow, this is what I wanted to show. So I definitely love this method reference syntax with my that you should know that what's going to happen here. So you need definitely some experience first when you read someone else's code, that when you can see these double colons, be reminded that oh, this is this method reference. And that if you really want to understand what's going to happen here, you have to go to the declaration to see, aha, so this respects a B1 session, and then B1 session is handled accordingly. In the last episode I had a crash. Yes, I think that was the reason of the clash, and actually I didn't regard it as a warning, but Java warned me that this is a potential error, and actually it is, because it may be null, and therefore I'd number of activities here. I prefer to extend this a bit, that if this is null, then let return 0, otherwise return the size. Okay, but we have to sandwich into this, if I'm not mistaken. Yes, the get value may produce null pointer exception. Yes, because this is nullable. Actually, this is not nullable. It may happen, of course, if we really want to be 100% sure, because this is nullable. Why it is nullable? Because we never pump values into no. Let's change it to non-null. Okay, this warning goes away, and also B1 activities. So definitely our ViewModel, yes, then it says it's not needed. Right. Because this is not nullable, and then it's really the responsibility of the ViewModel and our application. Do not push into these live data streams null values. A null value is pushed means that it was cleared. But that could be the discussion for another session.